Assalamualaikum warahmatullahi wabarakatuh. My name is Fakhri bin Zunaidi and my matrix number is B0517101004. And the title for my final year project is Study on Graphene Nanopellet Surface Modification for PANI GNPs NANOCOMPOSITE. First, I'm going to talk about the introduction. The graphene nanopellets configuration has drawn research interest due to the carbon atom arrangement close to the honeycomb network structure. Also, in addition of the graphene nanopellet to the polymer, could boost the properties of the mechanical properties and resulting nanocomposite. It was also attributed to its ability to electrical better than copper and to strengthen the surface barrier properties due to its platelets-like morphology. PANI has recent interest due to unusual electrical behavior also being subject into considerable better environment stability in dope and natural region is in synthesis and board using in various area. For the problem statement that have occurred, there are two problem statements. The first is the possibility of agglomeration caused to the increased graphene surface region. Second, in order to enhance the conductivity of PANI nanocomposite, the graphene nanopellets need to be surface modified to ensure good filler dispersion and better electrical current path network. Next are the objective. The objective for my research are to characterize the modification graphene nanopellet using for transform infrared spectroscopy (FTIR) and scanning electron microscope (SEM). Second are to observe the graphene nanopellets nanofiller dispersion within the polyaniline polymer matrix in relation to the surface modification impact. The scope for my project is to focus the preparation and testing of polyaniline polymer with the graphene nanopellet with modification or non-modification at the filler to compare to the treatment surface and the result of the morphology. The filler of graphene nanopellet being added to the PANI matrix with a composite of 0.25%, 0.5%, 0.75%, and 1.00% as the filler loading. Third are the PANI GNPs being tested and categorized for the morphology of observation using SEM and chemical composition using FTIR analysis. Next, we go into the literature review. Literature review for the graphite nanopellets. Cartal D. ETAL 2018. In the finding, graphite properties depend entirely of the number of layer and defect that occur on the graphene layer, the surface area of the several layer of graphene and graphite oxide, and the certain other variation emerge less in the single layer of gap. Graphene may have adequate conductivity when combining with glass fiber, polymer, and other matrix. Next, I'm going to talk about the polyaniline literature review. Liao ETAL 2018 says PANI have good thermostability and can be easily synthesized by an electrochemical method in the various organic solvent or even in aqueous media. Modana ETL 2013 says PANI has been associated with the numerous properties such as magnetic properties, electric and dielectric properties, redox properties, and antiredox properties. Next, Nicole ETL 2017 says the PANI has a higher stability at room temperature and it aids of conversion into the semiconductive material through doping. For the modification of graphene nanopellets, Relay ETL 2010 says there are four commonly documented methods for the non-covalent modification. There are cation interaction, anion interaction, and hydrogen bonding, also surface interaction. Zhu ETL in 2011, graphene has effectively modified to disperse graphene in polymer matrix using cation and anion type interaction. Tayumanavans ETL in 2015 says inorganic or aqueous solvent sufficient may successfully exfoliate multi-layer graphene nanosheet. For the methodology, the material that I will use is the graphene nanopellet, aniline chloride, ammonium trisulfate. For the modification of graphene nanopellet, ethanol and distilled water are added into the graphene nanopellets and polyterminate. After that, the mixture has been in the ultrasonic bath with the 1000 rpm at the 60 degree for 5 hours. After that, filter the mixture while using vacuum filter at 60 kPa, washing it with dilute water. Dry in oven for 5 hours at 150 degrees Celsius and grind using mortar for a fine powder. After the sample have been grind into the powder, it's been testing using FTIR and SEM. Next, for the synthesis of PANI dot modification of graphene nanopellet. First, the aniline hydrochloride have mixed with the distilled water for the first mixture, and for the second mixture, ammonium has been diluted into the distilled water. After that, the both mixture have been pre-cooled at 9 degrees Celsius for 12 hours. Match the sample 1 and 2 have been mixed, add of DBSA and various offloading GNPs. After that, stir for 1 hour using a magnetic stirrer and then chill at the 9 degrees Celsius for 24 hours. After that, the liquid mixture separate using vacuum filter at 60 kPa. While vacuum, wash the mixture using distilled water and acetone. After the sample have been vacuumed, the sample have been dried into the oven for 60 degrees for 24 hours and grind into a powder using a mortar, sent for testing for SEM and FTIR. For result and discussion. For the 4 result, I'm using scanning electron microscopy SEM. For SEM, the shape of PANI globular was considerably altered by the presence of GNPs in PANI GNPs nanocomposite. In figure 4.1, the presence of graphene flake has distracted the globular agglomerates of PANI polymer at 0.25% GNPs addition. However, in figure 4.2 until 4.4 shows the increase of GNPs loading to 0.5%, 0.75%, and 1.00%. This was discovered that good integration between the GNPs nanofiller and the PANI macromolecules cluster was achieved, owing to successfully in situ oxidation aniline polymerization reaction that further dispersed in the GNPs nanofiller. Throughout the PANI cluster, flaky morphology with numerous flat and sharp surfaces can be seen, indicating improved GNPs dispersion. During in situ polymerization, the aniline monomer dispersion and polymerization into the graphene nanosheet layer by layer. For the FTIR, treated GNPs at 3740 cm, corresponding to CC benzene ring. At the 350 cm, it have a CC quinoid ring, and the peak at 2200 cm, corresponding to the CH in plane bending. The observation around 700 and 500 cm complemented to the CC bending from the benzene and quinoid ring. Absorption band around 3550 cm, corresponding to a group of sulfur dioxide SO3 formed of the doping with the GNPs. For the untreated GNPs, characteristic at the 1630 cm, corresponding to the CC benzene ring. For the 1400 cm is a CC quinoid ring. At the peak of 1200, corresponding to the CH in plane bending. The observation at around 700 and 530 cm complement to the CC bending from the benzene and quinoid ring. The absorption band at around 1412 cm, corresponding to a group of sulfur dioxide SO2 formed after doping with GNPs. Lastly, for the conclusion, PANI GNPs nanocomposite was successfully synthesized using the acid-modified method of aniline oxidation polymerization. Resulting PANI GNPs nanocomposite powder have been characterized for morphology and structure characteristic. SEM image of morphology demonstrate very well incorporation of GNPs within the PANI cluster due to active oxidation aniline in situ polymerization. For the FTR stating, confirm that PANI nanocomposite have presence of the functional in the group. That's all for me. Thank you.